Alrighty, this is part 2 of writing rules for linear functions on page 541 in your textbook, looking at example 2. This is writing a rule from a table. So as we look at example 2, I'm not going to rewrite the table, but I will rewrite some of the key points that we're looking for, and then we'll try quick check 2. So we're looking at a table that has x values and y values. And the first thing we need to know is this a linear function? Linear function has the same change in input over change in output each time. And so we see that the change in y over change in x is the same no matter which points we look at. We could look 0, 10 to 2, 7, or 2, 7 to 4, 4. We could actually look from 0, 10 to 4, 4. And it always is going up by 2. Or the change in x is 2, and the change in y is -3. So I've actually got this backwards. The change in y is on the bottom of that table. It's going down 3 each time. You'll notice that in the ratio there on the example 2. And the change in x, the x value is going up by 2. Now I had said, well, I could also use the points 0, 10, and 4, 4. Or I could use the very first point in that table, 0, 10, then the last point, 8, -2. So if I was to say, what's the change from 10, that's the very first y value, to -2, well, that's gone down by 12. And the same thing, from 0 to 8, well, that's gone up by 8. But if you notice, -12 over 8 simplifies to -3 over 2. So I could use any 2 points, and that ratio of the change in y to the change in x is actually our slope, -3/2. We also need to know the y-intercept. Remember, we said that the y-intercept is the point where x is 0. When x is 0, that means that point is along the y-axis. And so we can find that point in our table. When x is 0, y is 10. That's the very first point in our table. And so we use, again, the formula y equals mx plus b. This time, though, I'm using the slope I found from the change in y over the change in x, and the y-intercept, the value when x is 0, to write this equation. M is -3/2 x, and b is positive 10. Take a second to look at quick check 2. You can pause your video. I would recommend, and for this one, I'm going to write down the table here. I've got my x values and my y values, just to rewrite this table so that we can do our own discovering of what is the change in y over the change in x. Take this chance to pause. Look at that table. Okay, so the question asks, do the values in the table represent a linear function? And as we go, as we change x, so x is changing by 1, going up by 1, going up by 1. Each time that x value goes up by 1. Now let's look at the y value. From 2 to 4, we go up by 2. From 4 to 7, we go up by 3. And from 7 to 8, we go up by 1. So for it to be a linear function, this would need to be the same change in y over change in x. Now let's look at each of these. For this first, from point 1 to point 2, we have a change in y is 2 over a change in x is 1. Then we have change in y is 3, change in x is 1. Oh. And finally, change in y is 1 over change in x is 1. These are not equivalent ratios. And so the answer is no, it is not a linear function. Just to practice, if this were a linear function, this would be the same way we would find the slope. Since it's not the same slope, it's not a line, it's not a linear function. We would also be looking for the y-intercept. So this is a good chance just to practice that skill as well. If we found the same slope here, then we would look up here to find the y-intercept. It's the point where x is 0. So here I locate that on my table. There's x is 0, and the y value is 2. So if this was linear, then this would be our y-intercept. Since it's not, that is not going to help us. Alrighty, we will look at step 3 in our third video. If you have any questions on this example 2, feel free to reach out to me during office hours.